So, good afternoon and welcome to this webinar produced by AFRY Management Consulting. Part of a list of webinars we are producing and broadcasting regularly on different topics for the energy industry. I'm just waiting few seconds. I see the number of attendees are increasing, so let's wait just a couple of seconds in order to allow people to join, and then I will start. So, first of all, introduce myself. I am Antonio Nodari. I am head of Central and South Europe in Management Consulting division. Today with me, I will have two colleagues. Holttinen, Business Director, Wind Power, part of the Energy Division of AFRY, and Torsten Lach, Senior Principal in the Management Consulting Division and located in the Düsseldorf office. The webinar is related to the engineering demand management. But before we start, I would like just to remind you that you can ask questions, and you can do it through the webinar tool, so using the question panel. We will try to answer your question as much as we can. And the slide pack and the recording of the webinar will be emailed to all attendees as soon as they are available. So let's start. Before going to the topic, just a short introduction about AFRY. AFRY is a leading global engineering consulting firm with more than 20 years of experience in wind farm engineering and energy consulting. More globally, is a company of 60,000 people and roughly 1.9 billion euro revenue. This was the value in 2020. We are active in 40 countries with office, but we are, as concerning project, we are active in more than 100 countries. AFRY has 5 divisions: energy, which is dealing with the energy industry, covering all the value chain, from generation to transmission distribution, and to some retail aspect of the infrastructure. Then there is the infrastructure sector, which is covering all the assets related to the transportation, the buildings, but also water and environmental topics for infrastructure, and has also design and architectural capabilities. Then there is a process industry, which is the division related to the process related sector, like bioindustry, chemicals, pulp and paper, and mining and metals. Then the industrial digital solution, which is concern the manufacturing business, and where there is located digital capabilities to develop advanced automation, connected products, and IT solution. And finally, there is the Management Consulting division, focus on 2 main sectors, energy and bioindustry, and offering 4 main service: market analysis, strategic advice, operational excellence, and M&A and transaction services. Said that, I leave the floor to my colleague Isa to go more deeply into the subject.
Thank you. So let me start by introducing the challenge that we are facing. As we all know, wind power markets are growing and they will continue to grow in the coming decades. New geographical markets are opening up for project development, and they each come with their own unique set of technical, environmental, as well as regulatory challenges and peculiarities. While at the same time, emerging markets are gradually becoming more mature, when local supply chains are built up, authority processes become more standardized and streamlined, and international project finance becomes available. So this implies that project developers need to adjust continuously their engineering processes and organizations to better match the evolving markets, while also at the same time expanding into new emerging markets and getting prepared to respond to unique set of engineering challenges met at each new market. At the same time, wind power technology will continue to develop, turbine sizes will continue to grow, and technical specifications will continue to evolve accordingly. Turbines will also be built in new and more challenging locations, from tropical heat to Arctic cool, in deeper waters, more remote places, regions prone to tropical storms, earthquakes, tsunamis, corroding atmosphere, extreme cold and icing, etc. So it's obvious that the developers are facing a huge challenge. They are under pressure to scale and adjust their project development and engineering organizations continuously. Next slide, please. So the key questions that we are trying to answer in this webinar are the following. First of all, how to ensure that the delivery of engineering work packages in time, in budget, and quality. How to increase the output from engineering departments to cope with the increased demand. How to find the balance between rapidly developing technology and the long project lead times from site identification through design and permitting all the way until construction. And which activities and projects should be developed, should the developers focus internally, which part of the work packages should rather be outsourced. So Torsten, please go ahead with the next slide.
Thank you very much, Isa. We as AFRY, we have defined a framework to focus, optimize, and digitize our design activities for on and offshore wind projects. And we call this framework engineering demand management. Engineering demand management consists of 6 levers. Lever number 1, engineering operating model. Lever number 2, lean EPC processes. Lever number 3, digital engineering. Lever number 4, technology and variant management. Lever number 5, resource management. And lever number 6, global engineering hubs. We will explain all these levers in more detail in the following charts of our webinar. But maybe as a start, when you run an exercise to scale your engineering organization or to improve the output of your engineering organization, we as AFRY, we recommend to look at all the levers at the same time at the beginning. But typically, over the course of the projects, there are 1 or 2 aspects your organization would focus then first. Let's start with lever number 1, engineering operating model. The engineering operating model is a blueprint how the engineering organization works. Your organization, your operating model should be aligned, of course, with the corporate engineering strategy, and it should describe how roles and responsibilities are, how processes are defined in the interfaces to the functions. It should describe the organization model, the governance structure, including approval routines, your future capabilities, including an analysis of the current capabilities and the qualification recruiting plan. It should describe, the target of your organization and KPIs to measure the progress of your corporate development activities, and also the systems you want to use in your engineering organization. It's a very big and broad topic, the engineering operating model. Let me just highlight two important aspects with respect to the wind engineering challenge. Number one, it is important to find and describe a balance in terms of budget and resource allocation when describing an engineering operating model. A balance between renewables technologies, but also between regions and also between central engineering and project organization. And the second aspect is if you have only limited resources, but a full project pipeline you need to focus on, you need to think about core capabilities, core competencies. And we believe that project development with asset management, site selection activities, package management, but also wind farm design, architecture, and LCO optimization, and the classical PMO stuff, that these are core capabilities. And we also believe that you need to become excellent in managing the solution contributors. This means your partners, your suppliers. This starts with a technical understanding of the wind systems, but also continues with a good supplier management and being able to technically manage the contract. Lever number two, lean engineering. Lean and standardized engineering processes across the whole organization and across all projects are a key success factor to manage the increasing demand for engineering processes. On the left-hand side, you see the AFRY project management framework, we call it Propeller, and we apply this framework at all of the projects in engineering. So in on and offshore wind development and PV, but also in the bioindustries and all the other industries. And we check the compliance of the individual projects against this framework on a continuous basis. I personally consider collaboration across multiple functions to be particularly important in order to improve the performance of your project development activities and in order to avoid deviation from the plan. A good example is here the technical change process. So design changes have, of course, an impact on the design organization, but they have also impact on the manufacturing organization of the procurement department because they need to renegotiate supplier contracts, for instance. It has an impact on budget and an impact on schedule. And therefore, engineering changes need to be treated and worked in a multifunctional team. If this is not the case, you have intransparency and the risk of deviations. The same applies to risk and claim management as well. Esa, please continue.
Yes, thank you, Torsten. On this slide, we are showing a very simplified illustration of the engineering workflow during project development. In practice, of course, these different engineering tasks shown here, they are not separate and consecutive, but they are rather interrelated and iterative in nature. For example, you may need to downscale your project due to findings of the grid studies by deleting some of the turbines in your layout. And after that, you need to rerun your layout optimization and energy yield assessment. Or some of the turbines may need to be relocated due to findings of your environmental studies. So the key question here is how to manage the complicated process without exceeding your budget or missing your target milestones or over-exhausting your engineers. First of all, obviously, you need to plan ahead and include sufficient buffers for unpleasant surprises in your timeline. And you need to ensure the continuous flow of information between the various technical and non-technical work streams. However, avoiding overflow of information. So we are talking about knowledge management, which is in a key role here. You should train your engineers to understand the bigger picture so that each specialist understands how their work relates to and impacts other work streams. For all these, using state-of-the-art tools and methods helps by speeding up the processes, by reducing uncertainties, and also making reporting and knowledge management more efficient. Next slide, please. One of the key challenges in wind project engineering is, of course, the increasing the growing turbine sizes. The turbines are still growing bigger and bigger, and technical specifications are evolving accordingly. While, on the other hand, the project timeline from site selection and initial studies all the way until construction is typically 5 to 10 years. And for offshore wind projects, it can be even substantially longer than that. So this means in practice that when you start your project, you really don't have a very clear idea of the optimal technology available on the market at the time of construction, especially knowing that the timeline for project development is always uncertain. However, from the authority perspective, you should know what you will build, where, how, and when to be able to assess the impacts of your project, which again is necessary for them granting you the permits to move ahead and proceed until up to construction. So how can you fulfill the requirements of permit authorities and regulators at each stage of permitting and contracting without freezing your design too early and ending up either using non-optimal technology or alternatively having to return back to square one with your environmental impact assessment and permit application? To do this, you first of all need to maintain close dialogue with OEMs and contractors throughout your project development and engineering. So managing your solution providers, as Torsten pointed out previously. You need to understand the market dynamics to have a clear picture of what to expect in the coming years. Also, you need to maintain close and proactive dialogue with authorities and regulators, and you need to make them understand the technology-related uncertainties. This is especially important when entering new, less mature markets where authorities have less experience and understanding of wind power technology. Again, I need to point out, keeping close internal dialogue between technical and non-technical work streams and sharing of information and knowledge management are key factors to succeed. So basically, you should only freeze your design where and when it's necessary and keep as many options open as possible within the permitting and contracting framework. Noting, however, that to the extent to which you can do this, of course, varies from market to market. Torsten, please continue with the next slide.
Thank you, Esa. Let's focus a little bit on resource management. If you have only limited engineering resources in the full project pipeline, you have to run a strategic-oriented and tool-based resource management. First, in order to size your organization, but also to ensure that your engineers are allocated to the most critical and most strategic relevant tasks and projects. To maximize the utilization of your own department and regional offices is also very important in resource management. At AFRY, our resource and demand management tool and approach considers the following aspects. Number one, we listed all the engineering activities and the related capacities. We also have a clear understanding about our project pipeline and the resulting demand for engineering work packages per engineering activity. We know our engineering resources by numbers and our recruiting plans. And we have also developed and agreed a clear in and outsourcing strategy, defining which activities we can give to the external market or want to give to the external market, and which are very critical. The criticality of each project and each customer is estimated, and we also look at regional specific aspects. And all these different aspects we consider in a structured and systematic way in order to make sure per engineering capability, per department, that our internal resources focus on the most critical tasks and projects. And we repeat this exercise on a continuous basis. If you're not applying strategic resource management, we see a tendency that resources are allocated on a first come, first served basis with negative impact on project performance and also company development. Lever number 6, global engineering network. Wind energy generation is a global business. Therefore, you need to plan which activities you want to do centrally and which you want to do in these regions. We at AFRY, we establish our own global engineering network with varying focuses on the offices. So we established central engineering offices focusing on certain technologies or industries or customers or even capabilities like testing or machine learning. And we have regional offices working on, for instance, project execution topics like grid connections or project development activities like land acquisitions. We are also sharing our offices with other AFRY engineering divisions. For instance, in China, our teams are co-located with the AFRY automotive engineering teams. On the left-hand side of this chart, you see, then an overview about our own AFRY wind network. Important is when you set up a global engineering network, you need to ensure that you define engineering processes and structures centrally, and that you make sure that they are followed on a global basis. You also need to make sure that the lessons learned you see in the projects across the world are fed in a structured and regular manner back to central engineering in order to make sure that they learn from the project execution, make sure that these learnings are fed into the reference designs and that you do not repeat the same mistake again. Conclusion. To deliver the strong growth of wind generation capacities, the wind developers are currently under pressure to scale their project development engineering organization at SSS and to further enhance engineering efficiency. We as AFRY, we have defined engineering demand management framework consisting of 6 levers. You need to define a blueprint how engineering operates and need to become excellent in project development and managing the solution contributors. You need to optimize and standardize processes in engineering and project management, use state-of-the-art tools, and make sure that everyone has access to the most and the relevant information. Integrate new technologies into your design. Integrate non-technical work streams in the engineering processes and work as a multifunctional team. Apply strategic resource management and set up a global engineering network. It is important that this engineering demand management, it's not a one-time effort. It is more a cultural transformation and a continuous improvement exercise towards a more global and lean engineering organization. Thank you for listening.
Oh, thank you, Asa. Thank you, Torsten, for your presentation. Looking at the demand, the question that we got also before the webinar, I have already one question for you, and is related to the how to manage these demand engineering needs in, let's say, less developed countries, or when entering new countries that are a little bit less developed from infrastructure point of view. So maybe Asa, you could answer this question.
Yes. So of course, when entering a new market where there is very limited experience, previous experience in wind power projects and technology, you should start expanding your engineering activities very cautiously and gradually. Usually the best way for starting your activities in a new market in such case would be using local subcontractors or partners to handle the local aspects, such as where you need to understand the local building code, the local grid code, and so on. while the major volume of engineering work for your first projects in such a market would be done by a regional or global engineering hub. And then step by step start recruiting local engineers, local specialists, and perhaps arrange a mentoring program so that you would use your senior staff, senior experts of the engineering hub to educate the local new recruits into the wind technology specific aspects.
Okay, thanks, Esa. I think it's quite clear what you said. I have another question, maybe for you, Torsten, or maybe let's say two questions in the same. What are, how we can summarize the main benefit that structured engineering demand management can bring to an organization? And also, I put also the second question for you: how companies should manage recruiting activities for their staff, and how to, properly align with the outcome of the engineering demand management exercise. So, if you can ask the question, please.
Thank you, Antonio. So coming to the first questions regarding the benefits of engineering demand management, I see more or less three main benefits. The first one is a very strong focus of the organization. If you run this exercise, the organization is clearly aligned towards the corporate and engineering strategy and target. And if you run this properly, your resources are allocated to the most critical tasks and projects. The second one is, of course, increase in efficiency when working on process optimization, integrating digital solutions, and so on and so forth. It's hard to give a precise number, but what I can give as a range is about 10 to 30% increase in engineering throughput, depending, of course, on the type of project and the maturity of the organization. And last but not least, it's also much lower deviation from the plans. This is what we have at least received or seen when we implemented this framework here at AFRY. So lower deviations from the project budget, the schedule. And this is, of course, also a big benefit, because in EPC business, you always plan risk margin in it. And if you are more stable in your processes, you are able to reduce the risk margins, which can give you a big advantage in the sales or in the margin then. Regarding the second question, if I still remember, alignment of recruiting to the engineering demand management, yes, this is clearly aligned. When you talk about engineering operating model, of course you can, of course you need to see what capabilities you need in the future, and what capabilities you need to see in the future. And when you have a gap, there are just two possibilities to manage it. First, you run through a training and qualification exercise. The second one is to recruit. And the same thing applies, of course, as is already highlighted, when you set up a new engineering office in the region. Of course, you need to utilize the local resources and the qualification and the qualified people there by recruiting exercise.
Thanks, Torsten. Is clear. By the way, we just got another question, which is, I think, is well aligned to what you were saying, and maybe going a little bit deeper. So, one of our attendees is asking, what are the activities that a company must be cover itself and no, without delegation or without outsourcing to a service or engineering company. So substantially, what are the key core activities that, in your opinion, a wind farm developer, a wind farm company should keep inside and get competencies and capability inside? Who would like to answer? Esa, Torsten?
Maybe Torsten, if you start, I can then continue if I get.
Yeah, then I would like to give a more let's say broad overview, or maybe you can go a little bit into detail with all your engineering expertise then, Esa. So of course, you know, one of the main key activities you need to consider to have in-house is everything related to project development. You know, from site assessment to overall wind farm, let's say, design, understanding, LCOE optimization, and overall project management responsibility. The other aspect is, of course, also if you outsource and if you partner, you need to have the capability, you know, to manage the supplier properly, starting with a technical understanding about the work packages you outsource, but also regarding, you know, managing the contract, which means setting up the contract, claim management, and so on and so forth. Maybe you can add something on the engineering side, Esa.
Well, actually, I think, Torsten, you covered this pretty well in one of your slides where you highlighted the sort of key issues that the project developer definitely needs to keep in his own hands. And these are asset management, site selection, overall project management, and conceptual and basic design, including the wind-specific engineering issues such as the layout design, the wind resource assessment, and understanding of the tools and methodologies for that. Overall package management throughout the procurement planning and the actual procurement phase, the LCOE optimization, and then of course the overall integration of the various work streams, including the non-technical work streams, environmental, contracting, financing related, all that, keeping that keeping that in your hands. And then the detail work, whether it is for let's say detailed engineering design or detailed environmental studies or whatever, the more detailed work can to some extent be outsourced. And this again comes back to the market you are working at, your existing competencies and resources, and your overall recruiting and organizational development plan, and so forth. But I would say the key issues really are understanding the big picture of the entire project development timeline, all the risks related to uncertainties, whether it's related to permitting or financing or the market-related uncertainties, or understanding the uncertainties related to technology development. These you need to keep in your own hands.
Okay, thanks, Esa and Torsten, for this answer. I have again another question now from the audience that partially reflect some of what we already mentioned, but maybe we can outpoint better the point. So, particularly when expanding in new markets, and generally speaking, new markets could be also, you know, markets that a company doesn't know, but is not necessarily an undeveloped market. What are the most critical functions to recruit in order to start the activities in this market? So what are the functional capabilities that you need to have from the beginning, let's say, when starting an activities in a new market? Esa, would you like to answer to this point?
Yes, I could try. Of course, again, each market may be slightly different, so there is no like single silver bullet to solve to answer this question. But and it also depends on the strategy of how you are planning to enter the market, whether it's by becoming a greenfield developer or by acquiring ready developed projects, or both, or something in between. But whichever way, I think you need to start actually with the non-technical issues. If it's about greenfield development, it's about land acquisition and permitting and consenting. If it's about project acquisitions, it's market screening and then getting contacts to project developers and starting discussions and understanding the market related issues. So all this is really something else than pure engineering. And for these work streams, you need to have either local partners, subcontractors, or hire your own personnel, preferably hire your own staff, because these are really strategic functions. Because you need to be able to handle these things with local language. You need to understand the local business culture. You need to know the local players. You need to not just speak physically the language, but also to speak sort of culturally their language to become a successful project development in that specific market. When it comes to engineering related issues, I think grid connection arrangements are something that typically require, first of all, understanding of local policies and frameworks. And often they also may need to be handled in local languages, especially in emerging markets. And again, may involve some sort of, let's say, educational discussions with the grid connection authorities, regulators, and grid companies to make them understand the specifics of the wind technology. So for these functions, you need local people, local electrical engineers to handle the processes. And again, since this is very much a strategic issue for the company, I would recommend starting to find your own engineering staff to handle these issues locally when entering the market. As a sort of a bridge solution to get there, you can of course find an engineering partner like AFRY, for example. We have engineers, electrical engineers, who can handle these conversations and contacting and sort of getting the work to start for you in a number of markets where we are active and where we understand the processes and so forth. But of course, you can't rely on external partners in the longer run. But for initiating your process, your engineering and project development process in a new market, a company like us, we can of course support you.
Thank you, Esa. Clear. Look, I have also, I personally have an additional question, and particularly with for Torsten. We are, addressing and having conversation with different type of organizations that are developing, wind farm in different countries. And according to you, I know that you have been involved in different activities. So what are the top challenges that you see when having this conversation with the client? Because we know that the expectation of wind farm development in the next year is extremely high. Does a client have these issues to really, realize a larger set of plant in many countries? So what are, at the end of the day, the key top challenge that you see for them and in front of them to achieve their objectives?
I would say first, standardized engineering processes integrated into the overall EPC process landscape across the globe. This is still a big issue we see, not so much in the headquarter, but especially in the regional organizations. A second challenge I see is integration of suppliers from the beginning of, and building a trustful relationship with the suppliers. So when something happens, that you can solve the issues, let's say, in a partnership approach. And another topic I see is, I would say, an underestimation of from the mother company, from the headquarter, of the local requirements, politics, culture in the different regions. So do not underestimate this. From my experiences, this was always a root cause for bigger deviations in terms of cost and schedule.
Okay, so thank you very much, Torsten. Look, I don't see any additional question coming, and by the way, we are closing also our planned time. So I would like to remind you that you will receive the deck presented and the video recording of this section very soon when it's ready. Obviously, you can contact our expert directly. You see here, and you will find in the presentation their email, Torsten from Management Consulting, Asa from Energy Division, Wind Power. And we will anyway keep you aware about our next webinars that, if I'm not wrong, will restart after the summer break. So I take also the opportunity to wish you a good breaks for those that has to still go in vacation, and see you soon with our webinar. Thank you very much for your attendance.
Thank you very much. Bye-bye.